Hi, this is Mr. Lonergan. It's midterm exam, practice 2. We're going to look at reciprocal functions, question 4 and question 5. 4 says, use the following graph to answer the questions below. I know this is reciprocal function because I see two separate pieces that are disconnected. A reciprocal function literally means I have to have a jump in the domain or a jump in the range where parts of the domain or range are undefined. It's because I have trouble when I get close to dividing by 0. Let's see if I can answer the questions and you'll see what I mean. First one says draw in the vertical and horizontal asymptotes. My vertical line is going to be right here. Uh-oh. Wonder who that could be. We'll let it ring. My horizontal is going to be along this is adding so much tension to our video. I love it. Who's calling? What do they have to say? What is the equation? So there's my vertical asymptote in orange, and there's my horizontal asymptote in blue. Next one says, what is the equation of my horizontal asymptote? A lot of us have trouble with this. A horizontal line, you're going to write the equation as y equals. And to figure out the value for y, you're going to look at where does it cross the y-axis. In this case, the y-coordinate of all of the points on this line is positive 1, because it crosses right there at y equals positive 1. So the equation is y equals 1. When I switch to vertical, I also switch from y to x. X equals. I go to my orange line and I say, where does this cross through the x-axis? Positive 1, positive 2. All the points on this line have an x-coordinate of 2. Now it's time to make the switch to looking at domain and range. Domain has to do with x, range has to do with y. So I'm going to start with, let me start with x. When I'm describing the domain, I'm looking at all the possible places where x is part of this function. There's arrows that say it goes to the far right. There's arrows over here that say it goes to the far left. The only place where this isn't defined is this one orange line where I have to jump over it to still be part of the function. So I'm going to write my domain. So I describe my domain as x is not equal to 2. Because that's the one place where it is not defined. For y, it's the same idea. I have arrows pointing down. I have arrows pointing up. The one place where the y value is not defined is right here where my blue asymptote is. So that I'm going to describe the range by saying y is not equal to 1. I could write it in different ways, but this is the most efficient. Okay. It's Mr. Lonergan again. My camera keeps dying, so let me be brief. End behavior. As x approaches negative infinity, that means the left side of the graph. Let's look what's happening on the far left side of the graph. We got an arrow. It's not going up towards positive infinity. It's not going down towards negative infinity. It's flat. And it goes back to our asymptote. So we'll say it this way. As x approaches negative infinity, y approaches 1. Positive 1 is where that asymptote is. Next, we're going to look at the right side of the graph. As x approaches positive infinity. The arrow over here is doing the exact same thing. As x approaches positive infinity, y is going to get closer and closer to being equal to 1. So then I have to think, what would my equation be for this graph? I'm going to look back at my picture with my asymptotes. I know that my original asymptote should be at 0, 0. And instead I've moved it 2 to the right and up 1. So my equation originally is 1 over x, but I'm going to make it go up 1 and right 2. So that's going to become y equals 1 over, this is where I always mess up, because I'm moving it to the right too, I'm going to do x minus 2. And if I want to, I can put parentheses around there. But it's already grouped because it's under a fraction. And then on the outside of the fraction, I put a plus 1. There's my equation. Very last part. Using words and pictures, explain what an asymptote is. We've been talking and talking and talking about it. An asymptote is a boundary line that the function approaches but doesn't touch. Okay? We talk about that and see in a lot of different places. Right here is a great example. This orange line is a boundary line. That function value gets closer and closer to being positive 2, but is never going to equal it exactly. Thanks. Bye-bye.